Hello students, welcome to all. Myself Kishore N. Gujar, Assistant Professor, Department of Physics. Today I am going to explain the topic band theory of solids. Now let us see the formation of energy bands in solids. In an atom, every shell associated with the energy. Electron orbiting in the first shell, which is very close to the nucleus and tightly bounded to the nucleus and have lowest energy. Greater the distance from the nucleus, highest will be the energy, which means that electron present in the outermost orbit have maximum energy. Due to the highest energy in the outermost orbit, electrons are easily extracted out, and these electrons are called valence electron, and these electrons are responsible for the formation of energy bands in solid and also in chemical reaction. Now let us consider isolated atom. Let us assume that isolated atom which consists only one electron in the outermost orbit, and these electrons have energy E1. Now let us consider the two atoms. When the two atoms are separated by a distance, then these two electrons have same energy. When these two atoms are brought close together and it forms an interacting system, in this interacting system, the wave function of the electron overlap with each other. Therefore, energy corresponding to the wave function split into two separate energy levels. So this is accordance with the Pauli's exclusion principle. According to Pauli's exclusion principle, no two electrons in a given interacting system can have same quantum state and hence same energy. So that's why when the two atoms are separated by a certain distance or far apart, these two electrons have same energy, but when they are brought close together, it forms combined system or interacting system. In the interacting system, the energy level is split into two separate energy level. Now let us consider the three atoms. So when the three atoms are separated by a certain distance, these three electrons have same energy, but when it is come into the interacting system, then the energy level of an electron split into E1, E2, E3. In the same way, we know that in the crystalline solids or in solid, it consists of n number of atoms, and these atoms interact with n minus 1 number of atoms in the solid. So that's why the energy level is split into a large number of closely spaced energy level in solids. Now let us see the formation of energy band with an example. Let us take the example of diamond. So here in diamond is nothing but a carbon atom. Carbon atom which consists 6 electrons. So out of these 6 electrons, here the 2 electron is present in the innermost shell, that is K shell, which is completely filled. Next to the K shell there is L shell. In order to fill this L shell, it required 8 electron, but there is only a 4 electron present in the outermost shell. So these 4 electrons are called valence electrons. And these valence electrons are responsible for the formation of energy bands in carbons. The electronic configuration of carbon atom 1s2, 2s2, 2p2. For each carbon atom has 2 1s state, 2 2s state, 6 2p state. Out of 6 2p state, 2 states are filled and 4 states are empty. When n number of carbon atoms are brought close together, there will be 2n available state for 1s, the 2n available state for 2s, and 6n available state for 2p respectively. Now let us see the formation of energy bands in carbon. When n number of carbon atoms are brought close together, so here the 1s level is split into 2n number of state and which consists of the 2n electron. In the same way, the 2s state is split into 2n state and which consists 2n electron, 2p state which is split into 6n state and 2n electron. When if you further decreases the interatomic distance, so here this is the original energy level of the electrons. If you further decreases the interatomic distance, the sum of the electron have energy, higher energy, and some of the electron have lower energy. Similarly, in 2p state, this is the actual the state of the energy level. So when the atoms are brought close together, some of the electron have higher energy and some of the electron have lower energy. That is depending upon the distance of electron from the atoms. Here some of the electron have higher energy and some of the electron have lower energy. These lower energy levels are approaches towards the 2s state. In the same time, here the sum of the energy level have higher energy and some of the energy have lower energy. This higher energy state is approaches towards the lower energy of 2p state. That is because when we reduce the interatomic distance, here the 2s and 2p states are very close to each other. So that's why these electrons is start to approaching each other. So at this point, so there is no separation line between the 2s and 2p state because here the 2s and 2p states are very close to each other. At this point, the 2s and 2p states are merged with each other, so and it forms a single band. That single band which consists of the 8n state and 4n electron. Here the electron move freely in the single energy band. So some of the electron have gained the higher energy and some of the electron have a lower energy. If you further reduces the interatomic distance, here the filled energy states and empty energy states are separated out. The filled energy state which consists of 4n state and 4n electron, and empty energy state which consists of 4n state and 0 electron. This filled energy state is called as a uppermost filled energy band. This uppermost filled energy band that is called as a valence band, and this is the lowermost empty band that is here what we call a conduction band. So this is called as the lowermost empty band. That is because, so in addition to this, there is 3s, 3p, 3d level, and these also form energy band here, but these are the empty energy band because there is no electron present in that band. As compared to this band, this is the lowest empty band. So that lowest empty band, that is here what we call a conduction band. In between these valence and conduction band, there is an energy gap. So here the reduction of the interatomic distance is possible until it reaches equilibrium. So after this point, there is no further reduction of interatomic distance is possible. So that's why here we draw the band diagram at this point. So here this is the highest occupied band, or it is a filled band, that is called as the valence band, and this is the lowest empty band. When we extended this diagram here, so here we can draw a band diagram. So here for 1s state, which consists of 2n state and 2n electron, which is completely filled, and next to this state there is the 4n state, and which consists of 4n electron, that is called as the valence band. Next to the valence band there is an energy gap, so there is an energy gap. Next to the energy gap, which consists of 4n state and 0 electron, this is called as the conduction band. In this way, there is energy bands are formed in solids. Next, we will move on to the classification of solids on the basis of energy bands. So before going to that, first we have to know some of the definition. The closely spaced energy level for electron in a particular orbit of different atom in a solid are known as energy bands. So we know that the valence band, it is the uppermost filled band, is called valence band. The conduction band means next allowed energy band above the valence band is called conduction band. Next one is forbidden energy gap. The energy separation between the valence band and conduction band is called forbidden energy gap. On the basis of band theory of solids, solids are classified into conductor, semiconductor and insulator. So in conductors, valence band, which is uppermost filled band, and empty conduction band is overlap or separated by very small distance. Since this valence band, which consists of electron, but it has no empty energy bands. But here in conduction band, there is no electron, but it consists of a large number of empty energy bands. So that's why when valence and conduction bands are overlapping each other, then electron from the valence band is moved to the conduction band. So here it consists of large number of energy level. So that's why electrons are free to move in the energy level, and it forms conduction in conduction band. So example for the conductor is all metals. So what we say, in other words, in conductor, valence band and conduction band are separated by very small distance, or they are overlapping each other. Next, semiconductors. So as name itself suggests that semi means half. So semiconductor is nothing but half conductor. So half conductor means the material whose electrical properties lies between both conductor and insulator, that is here what we call semiconductors. Why it is called semiconductors? Because in semiconductors, this completely filled valence band and completely empty conduction band are separated by very small distance. So here the energy gap of for silicon semiconductor is about 1.1 electron volt, and for germanium the energy gap is 0.7 electron volts. So here in semiconductors, the conduction takes place only when there is a electron as well as empty energy level. So here in valence band, it consists of electron, but there is no empty energy level because all are filled. Here there is large number of empty energy level, but there is no electron. So that's why at absolute zero temperature, the no electron is available for the conduction in conductor, so it behaves like an insulator. As the temperature increases, electron gains the energy and jump from valence band to conduction band. So in the conduction band, it is called as a free electron because in conduction band, it consists of a large number of energy level. That electron is free to move in the conduction band. So that constitutes the conduction in conduction band. So that's why at high temperature, so semiconductor is behave like an conductor. At absolute zero, it is behave like an insulator. At higher temperature, so here it behave like a conductor. So that's why here the semiconductor, it is defined as the material whose electrical property lies between both conductor and insulator. Next, we'll move on to an insulator. In insulator, there is large energy gap between valence band and conduction band. For example, for diamond, this energy gap is about 6 electron volts. So that's why. So here there is no conduction is possible between the valence band and conduction band. So if there is no conduction is possible, so then it's behave like an insulator. Thank you.